Okay, so now we move on to the very last part of this lesson. Okay, so where we take the loci of the we are going to find parts. We are going to find parts associated with these hyperbolas and what is it? Hyperbolas and ellipses. Okay, so let's see what we are talking about. So before we go into that, they have given a small summary of what we have done so far. Okay, can you see the parabola? Actually, parabola and rectangular hyperbola was discussed in F1, right? So it was not discussed in this book, right? So we discussed in this book mainly ellipse and hyperbola. That's what we discussed. So this book, they have given you a small summary to remind you about the parabola and the rectangular hyperbola, which are the two equations you learned in F1. Okay. Right. So anyway, we all of these things, except the Cartesian and the parametric equations, the equation of tangents and normal can be derived. Okay, so you can derive them and use them. Okay, so what we'll do now is let's actually go for the sums where we derive the locus. Okay, so let's see what is a locus. First of all, a locus means a path of points, right? Now, for example, in the case of the parabola, what is the parabola? Do you remember how the locus was defined for the parabola? In the parabola, the path was defined such that what? The distance from every single point on the path to the fixed point called locus, right? The focus, yeah, the fixed point called focus. So from any point, basically from any point, the distance to the focus and the perpendicular distance to the directrix were equal. That was how it was defined. Okay, so the locus of the parabola is defined by using this particular rule. Basically, every point in the parabola obeys that rule. Okay, so now what we are going to do here is we are going to describe a few more loci. Let's see how it's done. Question number 1, let's read this one. I think the first parts are not going to be an issue. It's the same thing that we did before. The last part is where we need to introduce you the locus. Let's see. The tangent at P, AP square, 2AP, and the tangent at Q, A cube square, 2AQ to the parabola. Can you see? We are back to parabola. Okay, fine. With equation y square equals 4AX. Meet at R. Okay, find the coordinates of R. Once again, do you want me to remind you quickly what's the parabola? In the parabola, the A is the focus, right? Do you remember A is the focus? So it's A comma 0, which is your focus, and directrix goes at x equals minus A. Okay, so this is the directrix. So basically the rule is the distance from any point on the parabola to the focus and the distance, perpendicular distance to directrix are equal. Okay. So now they say the tangent at P and the tangent at Q. There are 2 points called P and Q on your parabola. They meet at R. Find the coordinates of R. Okay, what's the first thing we need to do? The first thing we need to do is we have to generate the equation of the tangent at point P and at point R. Okay, let's get it done. So let's get the equation of tangent. How do I get the equation of the tangent? Whenever they give us ellipse or rectangle, hyperbola or parabola, how do we get the equation of the tangent? First thing is to get the gradient, dy by dx. Okay, so we have here y square equals 4ax, right? That's the equation of our curve. Let's get the dy by dx, because if you want the tangent, get the dy by dx. How do you differentiate y square with respect to x? First you deal with the power, right? So 2y to the power 1. After you're done with the power, go inside, differentiate y, dy by dx equals 4ax. When you differentiate, 4a times x differentiation is 1. So I end up getting here dy by dx is 4a over 2y. Do you agree? It's 4a over 2y. Okay, so then I can simplify this a little bit. Dy by dx is 2a over y. Is that okay? Okay, then they are saying you to find the, we are going to find the equation of the tangent. So we'll find the tangent at what's the point? Tangent at, what was the coordinate? AP square, comma, 2AP, right? Okay, so how do we get it? Let's get the dy by dx. 2a times the y value is 2ap, right? You have to substitute the y coordinate, isn't it? You have to substitute the y coordinate. Y coordinate is 2AP. Do you agree with me? That's what we do. We substitute the xy equation. Here there is no place to input x. So input the y. The 2a cancels and you get dy by dx of the tangent is 1 over p. Now let's get the equation of the tangent. So equation of tangent is y minus y1 equal gradient times x minus x1. Y minus y1 is 2AP, right? Gradient is 1 over p. X minus x1 is AP square. Is that okay? Continue. I'll bring the p to the other side. So p times y minus 2AP gives me py minus 2a p into p is p square, right? 1 times x minus ap square is x minus ap square. Are you all okay with that? So I end up getting here py. Shall I take the x to this side? Doesn't matter. I mean, they haven't given us any strict format. Py minus x equals minus ap square plus 2ap square. Simplify. Py minus x equals minus ap square plus 2ap square is plus 1ap square. Okay. Okay, so I found the tangent at the point P, right? Okay, so let's say this is my point P. Now they are saying again there's another point called point Q, right? And I need to find the tangent at the point Q. So are we going to like repeat this entire process again to find the equation of the tangent and Q? Look at the 2 points. Now the tangent at point P is AP square comma 2AP, right? Point Q is what? AQ comma 2AQ. Do you see the only difference is what? P and Q. The only difference is P and Q, right? Yeah. So then do we really need to do the whole process again? No. So then you could write simply, similarly, just write like this. Similarly, equation of tangent. Equation of tangent at where? At Q is what? Will be what? The only difference between the thing here is that instead of AP square, use AQ square 2AQ, right? So then the whole process is the same. That instead of PY, now you have QY minus X equals AQ square. This is the only thing. So you don't need to do the whole process again. Just a simple statement and you can write it. Save your time. And that's all. That's all you need to do. Because it's the exact same process will be repeated, right? With just the change in the letter. So you don't need to do the whole thing again. Okay. Then move on. So find the coordinates of R. Find the coordinates of R means I need to find, so this is point P. There's another point called point Q. So I'm finding the tangents at P and Q, right? Where they meet. So shall I make Q to a different point? Let's say Q is over here. So I had, what do they want? The coordinates of R means what? The place where the tangents are meeting. The place where the two tangents meet. Somewhere like over here. Are you with me? Okay, so then all you need to do is you have the two equations, tangent at Q and P, equate them. Right? So solve it simultaneously. Solve the two equations simultaneously and get me the values of x and y. So coordinates of R, we have to solve the two equations. Okay, how do I solve the two equations? Equate them in the sense you could make x a subject and put it in the other, or like, what could I do? Py minus ap square is equal to x. Do you see I made x a subject in the first equation? And in the other equation, you get qy minus aq square is also equal to x. Do you agree with me? So you could solve it in your own way, huh? And then I made the two guys equal. What I did here is, once again, I made x a subject in both the equation, taking x to the other side, taking ap square here. Same with here, taking x to the other side, taking aq square here. You understand? And then what I did is, since x is subjected, I just equated, substitution. Equated the two guys. And now what do I have to making y the subject? So I'll take y to one side, py minus qy. I take the y terms to one side. Take the ap square here, I get here AP square minus AQ square. Are you with me? Take Y out, I get here P minus Q equals. I'll take A out here, I get P square minus Q square. Do you agree with me? Y equal A times P square minus Q square over P minus Q. So is this the maximum that I can simplify, or is there any way that I could simplify further? I can factorize P square minus Q square. So how do we factorize P square minus Q square? It's called difference of two squares. A square minus B square is A minus B, A plus B. Likewise, P square minus Q square is P minus Q, P plus Q over P minus Q. So I could cancel off the P minus Q to P minus Q, and I end up in the Y coordinate as A times P plus Q. Get the X value. So how do we get the X coordinate? Substitute, right? So we'll substitute this equation. So X equals, let me put it into any one of the two equations. X equals Py minus AP square, right? X equals Py minus AP square. So I get here X equals Py is A times P plus Q, Py minus AP square. So when I open the bracket here, I get PA into P is AP square, PA into Q is APQ minus AP square. So plus AP square minus AP square cancels, and I get X equals APQ. APQ. So basically the coordinates of R are these are the coordinates of R. Is this okay? Let's go to the next part. The chord PQ passes through the focus A, 0 of the parabola. Show that the locus of R lies on the line x equal minus a. Okay. Look what they're saying here. The chord PQ. Now, when you say the chord, so basically you can see I just randomly marked my points PQ. So they say when we join these 2 points PQ, the chord will actually what? Pass through the focus. So basically my focus should be over here. Okay, so they say when we join the chord PQ, the chord PQ is supposed to pass through the focus A, 0 of the parabola. Then they are asking you to show that the locus of R. What do you mean by the locus of R? The locus, now you know R means the place where the two tangents meet, right? R is the place where the two tangents are meeting. They are asking you to show that the locus of R. What do you mean by the locus of R? The locus means it's like a path. It's like a path. Okay, so that means this point R is not fixed here. Why? Are the points P and Q fixed? No, the points PQ move, right? When points PQ move, as long as the points PQ move by making sure that the chord passes through the focus, then the tangents that you draw at P and Q, they are asking you to show that always, wherever you draw the tangents, the meeting point will come where? On the x equals minus a line. The meeting point R will be on the directrix. That's what they want you to show. Basically, wherever you move, this is the point. The point R will always fall on this line. Okay, that's what they are saying. They are asking us to show that. I'm not concluding that. That's what they asked me to show. Show that the locus of R. Locus means the path of R. The path of R will lie on the line x equal minus a. Okay, as long as what? As long as the chord PQ passes through the focus. Okay, so that's what they have told us. If the chord PQ passes through the focus, then we need to show that the point R will have the locus. The path of point R is on the line x equal minus a. That's what I need to show. I need to prove it. Okay, so then let's try to prove it. The first thing we need to do is what? They're talking about the chord PQ, right? So first thing is what? Let's find the equation of the chord PQ. Get the equation of the chord PQ. Part C. So what's my task now in part C? So always have an idea of what we are going to do. What are we going to do? We are going to find the equation of chord PQ. Okay, we are going to find the equation of chord PQ. First thing is what we are trying to find the equation of a line. We must first find the We must first find the gradient. So I think we have our 2 points, right? Point P is AP square comma 2AP, right? Point Q is AQ square comma 2AQ. Is that okay? So let's get the gradient. Gradient of the PQ chord is what? How do we get the gradient? We can't add and divide by 2. Adding and dividing by 2 is the midpoint. How do we get the gradient? Y1 minus Y2, Y difference, delta Y over delta X. We get the Y difference and the X difference. So Y difference 2AP minus 2AQ divided by X difference will be AP square minus AQ square, right? Let's take the common thing out, 2A. So I get P minus Q on top. When I take A down, I get P square minus Q square. Do you agree with me? We can simplify further. Yes or no? Yes, P square minus Q square can be further simplified as P minus Q, P plus Q. Difference of two squares in the denominator. The P square minus Q square can be written as P minus Q, P plus Q. It's called difference of two squares. And now what happens? The A to A can cut. And P minus Q to P minus Q also cuts. So what do you get for the gradient? 2 over P plus Q is the gradient of the chord PQ. Okay, so I have that. Now the gradient is there. Now it's time to find the equation. Let's get the equation. So how do we get the equation? Y minus Y1 equals gradient X minus X1. So Y minus, what is Y1? Y1 you could use as long, I mean you had to use a point that passes through the line. So our line is the PQ line. So if you want, you could use the P coordinate or you could use even the Q coordinate. Any one of them is fine. Any one of them is fine. Is that okay? I'll use P. Okay, even if you use Q, there won't be any problem. Its answer will be exactly the same. So Y minus Y1 is 2AP. Gradient was what? 2 over P plus Q into X minus, what is X1? X1 is AP square. Do you agree with me? Okay, so now let's take the P plus Q to the other side. So I get here Y times P plus Q, right? And minus 2AP times P plus Q. I took the P plus Q and multiplied it with both the terms, P plus Q with Y and minus 2AP times P plus Q. Do you understand? Equals here, I open the bracket with 2x minus 2AP square. Is that okay? Okay, 2x minus 2AP square. I think I can open the bracket and simplify a few terms. Y times P plus Q, I'll keep it. This bracket will open. Minus 2AP square minus 2APQ. Are you with me? Equals other side, you get 2x minus 2AP square. Can you see someone cancels? Minus 2AP square minus 2AP square on either side, which means when you bring it to one side, it will cancel out, will become 0. So we end up getting Y times P plus Q 2APQ equals 2x. Okay, so now the thing is, this is the equation of the chord PQ, right? Leave it like this. And now what do we know about the chord PQ? We know they have told us something extra about it, right? The chord PQ passes through what? The focus. So the chord PQ passes through the focus means what? It passes through A comma 0, right? So then what do? Go to your equation, replace the X with A, replace the Y with 0. Replace the X with A, replace Y with 0. What happens? Y times P plus Q. When you replace Y with 0, whole thing becomes 0 minus 2AP cube equal 2 times X is A. Can you see? So here then I can see the A to A will actually cancel. The 2 to 2 also will cancel, right? 2 times 1, 2 times 1. I end up getting minus PQ equals A. Oh, sorry, minus PQ equals 1. Or in other words, PQ equals to minus 1. So this is kind of like a relationship, like the relationship that P and Q must obey in order what? In order for this line to pass through the focus, like the points now. The P and Q are parameters, right? So basically what they're saying here is if the line passes through the focus, the point, the PQ parameters, the product must be -1. Okay, so we get that. What am I trying to do here? I'm trying to find what? Now I found the chord PQ. I know it passes through the focus. So I input them and I got this kind of relationship. What's the end goal? The end goal is to find the locus of R, right? How is this R behaving? When PQ changes, how the R will behave. Okay, so that's what we want to do. Now, didn't we already find the coordinates for R? How R behaves? Yes, we have R is, the x coordinate of R is what? For the coordinates of R, when we talk about R, the x coordinates of R is APQ, right? The y coordinates of R was A times P plus Q. So now look, you can see that we already found PQ is obeying this particular rule, right? PQ is -1, which means what? X equals -A. So that's it. I don't need to even go here. Because you know why? Now, P and Q are parameters, right? Whenever you get a equation with X or Y with respect to some kind of a constant like this, can you see there are no parameters in this equation? This is now a what equation? X equal -A is a Cartesian equation. It's not parametric because PQ are the parameters. They are removed. Do you get what I'm saying? So X equal -A is a Cartesian equation, which means the point Y is not a fixed person like this. So point Y is changing. I can't do anything for Y. But we know that as long as PQ product becomes -1, the X coordinate of R, the what coordinate? The X coordinate of R will be definitely on -A, which means it will move along this line. See, it will be moving along this line. Do you understand? As long as your P points PQ pass through the focus, the tangents drawn at PQ will definitely fall. They will intersect on the line X equal -A. So you get what's going on. So that is the locus. So they're asking the locus of R. Locus means you need to give your locus always in what form? A locus. Whenever they ask you to give a locus must always be given in Cartesian form. Cartesian form means what? There are no parameters. Do you see that X equal -A has no parameters? Okay, there are no parameters. So this is called this is the locus of R. Basically, all points of R will lie on this particular line. It's a Cartesian line. Okay, so there are no parameters. Whenever they ask you a locus, make sure you give a Cartesian answer. There shouldn't be any parameters. So this part we can cut, and this is the locus of R. Do you understand? So yeah. Then the next one, there's a part C as well, right? Look at part C. Given instead that the chord PQ has gradient, to find the locus of R. Okay, now are we saying that it passes through the focus of the parabola? No, given instead that what? The chord PQ has gradient 2. Okay, so if the chord PQ has gradient 2, let's move on to part C. The chord PQ has gradient. Part C. Okay, I'll write over here. If chord PQ has gradient 2, what's going to happen? Now we already got the equation for the gradient of the chord PQ, right? Gradient of PQ was 2 over P plus Q. Okay, so then now the gradient is how much? Gradient is 2. 2 equals 2 over P plus Q, right? So what happens now? I can get the value of P plus Q, right? P plus Q is 2 over 2, which means P plus Q is 1. I don't need to go to find the equation of the chord, okay? Leave it like this. What I want to do is what? Are they asking us to find the equation of the chord? No, they're asking us to find what? The locus of point R. So what was the point R coordinates? The x coordinate was APQ, right? We found earlier x coordinate is APQ, y coordinate is A times P plus Q. This time, which one do you think I should use? I don't need to go with x now because now I can replace the parameter P plus Q with 1. Do you see? So this time I'm proceeding with the y coordinate. So y equal A times 1, which means y equals A, and this is the locus. A locus means where you are able to get rid of your parametric parts and you are able to get a Cartesian equation. You know, sometimes you might now in here The y in this part the y came along, the horizontal line. The earlier one was a vertical line. But in the next set of questions, don't always expect to have only y and only x. The next part you might we might probably need to combine both x, y and give a locus house. Just be prepared for that as well. So in this case, we don't need the x. X is not going to be part of your locus. Okay, because it's going to be on the horizontal line. X coordinates will vary. Are you all okay with this? Okay, so then let's try another one now. Okay, let's go to question number 4. The ellipse E has equation x square over 25 plus y square over 9 equal 1. Okay. The line L1 is normal to the ellipse at the point 5 cos theta, 3 sin theta. Use calculus to show that an equation for L1 is this. Okay. So what you have to do? You have to do everything again from the beginning, right? So from the beginning, differentiate, get the gradient of the tangent, convert to normal, and you have to do everything from the beginning. So full, this is the 4-mark question. Let's get it done. So first start off with what? The differentiation of the ellipse equation. So let's differentiate. We've been doing this now for several times now. X square differentiation is 2x plus 1 over 9. I'll keep it aside. Y square differentiation is 2y dy by dx equals differentiation of 1 is 0. Then this is 2x over 25 plus 2y over 9 dy by dx equals 0. So 2y over 9 dy by dx equals minus 2x over 25. Is that okay? I can cancel out 2 and 2 and I end up getting here dy by dx equals minus 9 over 25 and x over y, 9 minus 9x over 25y basically. Is that correct? Then what we do is we need to substitute our point, right? What's our point? The point is 5 cos theta, 3 sin theta. Are you with me? 5 cos theta, 3 sin. Let's substitute x and y. So dy by dx of the tangent will be, tangent at P will be minus 9 over 25. X is 5 cos theta over y is, so 5 times 1 is 5, 5 times 5 is 25, 3 times 1 is 3, 3 times 3 is 9. Do you understand? So what do I get here? Minus 3 cos theta over 5 sin theta. Is this okay? This is the dy by dx of the tangent. Then I need to find what here? I want to find the normal. So dy by dx of normal means what? It's tangent and normal are perpendicular. So you can switch the sign and take the reciprocal. Basically, gradient product is minus 1. So minus becomes a plus. It's 5 sin theta over 3 cos theta. So now let's get the equation of the normal. So equation of normal, y minus y1 equal gradient x minus x1. Y minus what is y1? 3 sin theta equal gradient is 5 sin theta over 3 cos theta, right? Yeah. X minus what is x1? X1 is 5 cos theta. So I'll bring the 3 cos theta to the other side. I get here 3y cos theta minus 3 times 3, 9 sin theta cos theta. Is that okay? I multiply 3 cos theta with both. 3y cos theta, 3 into 3, 9 sin theta cos theta equals 5x sin theta minus 5 times 5 is 25 sin theta cos theta. So what do we get here? 3y cos theta. I'll bring the minus 5x sin theta here. I brought the 5x sin and I'm going to bring the minus sign to the other side. Minus 25 sin theta cos theta plus 9. These are steps that you could skip, okay? I'm writing extra steps here, but it's not necessary. Have they given a show that? 3y cos theta. They have kept the 5x sin theta on the other side, right? They've kept the 5x sin theta on the other side. 3y cos theta equals 5x sin theta minus 25 plus 9 is minus 16 sin theta cos theta. Is that okay? Right. So then this is the equation of what? This is the equation of the norm. This is the equation of the normal. Okay. Then the next part, the line L1 cuts the x-axis at M and the y-axis at N. Show that the locus of the midpoint of MN is this. Okay. First thing is what? The line L1 cuts the x-axis at M and the y-axis at N. So let's get the cutting point of x-axis. So when I cut the x-axis, you know y is 0, right? Put y 0. So 3y, y is 0. Are you with me? This is 5x sine theta minus 16 sine theta cos theta. What do I get here? 16 sine theta cos theta equals 5x sine theta. What do I get here? X is 16 sine to sine cancels, right? 16 cos theta over 5. Do you agree with me? Yes. It's 16 cos theta over 5. And this is the coordinate M O N when you cut x-axis. They say when you cut x-axis, the line L1 cuts the x-axis at M. I found, yeah, x-axis at M. So what's the M coordinate? 16 over 5 cos theta. Do you agree with me? And y coordinate is 0. Agreed? And also this same line cuts the what axis? This same line cuts y-axis at N, right? When you cut y-axis, x is 0. When you put x 0, what do you get here? 3y cos theta. The x is 0. 5x sin theta, x is 0. Minus 16 sin theta cos theta. Are you guys with me? So what do I get here? Y equals minus 16 sin theta cos theta over 3 cos theta. Is that okay? So I get here y equals cos to cos will cancel, minus 16 over 3 sin theta. So they say the line cuts the y-axis at the point N. So then what's the point N coordinate? N is x is 0, y is minus 16 over 3 sin theta. Is that okay? The first thing is you get the equation of your normal. They have told you to find the equation of the normal and they tell you the normal cuts the x-axis at M and the normal cuts the y-axis at N. So basically, when you cut x-axis, you set y0 and get the M coordinate, and when you cut y-axis, you set x0 and get the N coordinate. That part is okay, right? Now, what do we need to find the locus of? They are asking you to find the locus of what? Show that the locus of the, what is this? Midpoint. Show that the locus of the midpoint of MN. So that means you have to find the path of, not, you have to find the path that the midpoint of MN moves. Locus means to find the path. Find the path that the midpoint of MN moves. Okay, let's find the midpoint. The midpoint of MN. How do I find the midpoint? To find the midpoint, all we need to do is add the two x coordinates, divide by 2. Add the two y coordinates, divide by 2. So then let's add 16 over 5 cos theta. I had to add with 0. Divide by 2. This is the midpoint x coordinate. The other one, the y coordinate 0 and minus 16 over 3 sin theta. I had to add and divide by 2. Do you agree with me? So midpoint coordinate I have 16 over 5 divided by 2, because you can understand 16 over 5 divided by 2. Type in your cal, you get 8 over 5 cos theta. You need to realize this 5 comes down with the 2. The 2 and 16 will cancel. Okay, and comma, this one also the 3 comes down with the 2. 16 and 2 cancels. You get minus 8 over 3 sin theta. So this is the midpoint. Okay, they are asking us to find what? The locus of the midpoint, meaning what? Now this midpoint is not a fixed place, right? The midpoint is not in a fixed place. You can say midpoint is in terms of parameters. They are asking me to find the path that the midpoint is moving. So now if I take the midpoint's x coordinate, what's the midpoint x coordinate? 8 over 5 cos theta, right? What is the midpoint's y coordinate? Minus 8 over 3 sin theta. So what you need to do is now you have to find the locus of this. The locus. How do you find the locus? Meaning, I told you locus will not include parameters, right? Sine theta, cos theta, parameter. So your task is what? You saw the locus equation had both x, y, right? Now in the earlier question, the locus equation was just x equal a and some y equal, right? There was no x, y combination. Here, the locus equation, they have told it's a x, y combination. So what you need to do is get rid of the cos theta, sin theta and bring your x and y together. So this is something that we do in P2, eliminating theta. How do we eliminate theta here? How do we eliminate theta? By what is the primary equation we need to use to eliminate theta here? We use sine square theta plus cos square theta equal 1. That's the primary equation we need to use to eliminate the theta and get x and y together. Okay, so then what do we get here? I get here first 5x over 8 equals cos theta. Okay, which means cos square is what? If you square, I get here 25x square over 64. If I make sine theta the subject, here I get what? Minus 3y over 8. I switch the minus sign, switching side, or you can take the minus here. Minus 3y over 8. So when you square it, the minus will also get squared, right? Minus becomes plus 9y square over 64. So now it's time to eliminate it and give the locus. So locus, the locus of midpoint. Where is it going to be? It's the equation is sine square theta plus cos square theta equal 1. Sine square theta is 9y square over 64. Cos square theta is 25x square over 64 equals 1. Is this to show that? Yeah. This is to show that, right? 9y square over 64. Yeah, plus 25x square over 64 equals 1. Yeah, this is to show that. So basically, this is how you what? This is how you get a locus. This is how you get the locus. Where you eliminate the parameter and get the Cartesian equation. Okay? Do you understand?